Okay, let's try this, I think, pretty challenging question about a piece of wire 6 meters long that we're going to cut into two pieces. One piece we're going to make a square out of, and the other piece we're going to go from B to E to F to C on. I think that's what they say. One piece, we'll call it X meters long. So these four pieces together add up to X. It forms a square. The other piece makes this U shape right here. Okay, well, if this whole thing is X, then doesn't it make sense that the four sides, each side would be X over 4? That's your first big idea. Okay, there you go. Now this piece here, BE and CEF, they look like they would be the same length, AD would equal EF. Let's do that first, because it's a rectangle, right? So the ends must be the same. And then I would say that BE equals CF. And then these two things have to be the same. These two lengths have to be the same here. Well, the two lengths plus this whole thing that adds up to X, plus this X over 4 here, that has to add up to 6 meters. And then if we multiply everything by 8, there's 5X, we subtract it, and then we divide by the 8 in front of L. Hey, we've got a way of looking at the length in terms of X. And that's what we need for this min-max calculus. If we're going to find the derivative, we have to have it all in one variable. So that's our next step. We're going to find the area of these two squares. Well, the first one's easy because it's X squared. So that's easy. The first one is X over 4 squared. Obviously, it's not X squared. That isn't X by X, is it? It's X over 4 squared. There's the first square. The other square is X over 4 times this thing, 24 minus 5X over 8. And then you just multiply it all out, and you end up with 24X minus 32X squared. Now, all we have to do is take the derivative of this thing and make it equal 0. And that's what you do. The derivative of this, the top of this would be 24, and this would be 2 times 3 is minus 6X. You can actually put the 32 on the bottom. It just works because it doesn't affect this. You could break it up and into two parts and then take the derivative. You'll get the same answer. But this is the derivative. This is from the memo. The derivative is 24 minus 6X over 32 when you do it. And if you make it equal 0, you multiply by 32, you add 6X, divide by 6. 24 divided by 6 is 4. So that's the value of X, for which the sum of the areas will be a maximum. The maximum happens at the turning point of this function of area, where the derivative is equal to 0. That's the turning point. Yeah, that's the maximum. So there you go.